Okay, this video is for my Calculus 1. It's some integration practice, and I graphed a lot of these, and I'm going to show you how to use the calculator. The first is they want to evaluate these definite integrals, and as you look at the pattern that's going on here, you'll see that this is quite easy to look at. Well, this one is going from -2 to 2 of 5 dx. So this first part here, all I want you to do is basically put them in your calculator and just practice doing that in your calculator. So let's kind of do that together. So we're going to bring up your calculator here, and it's from -2 to 1 of 5 dx. So when you hit menu, hit calculus, and then you're going to see the word integral here. It's set up beautifully. So I can put a -2 here. Here I can put a 1 and a 5, and it's dx. So I'm going to put an x there. When you hit enter, you're going to have 15. And if you think about this, if I was going to graph a line that was y equals 5, and I go from -2 to 1, it's really a 5 by 3 rectangle. So that would be my integral, or the area under the curve. So this one's going to be 15. So as you go through this, go ahead and practice this. I have the answers on here, but go through and do these on your calculator and just practice finding the integral. The one thing I did want to tell you, this shouldn't be a division here. It must be when I typed it. This is radical 18. So I have the answers online. Just make sure you know how to put these in your calculator and come up and evaluate the integral. So you can actually find a number for those. What I want to spend time is starting on 7, where you evaluate the integral, and I want you to use a graph of the integrand and areas to evaluate. So I know you can put this right in your calculator and get the answer, okay? In fact, if you do, you should get a 21. So I already know the answer. But this is how I want you to evaluate it, is to graph this and then use the shapes that they're at to actually find the area. So I'm going to kind of set up here a nice little graph going on here. And I know I'm going from -2 to 4. So here's -2. 1, 2, 3, 4. And I'm going to actually plot the points. So let's kind of look at this, what this looks like when we graph it, because this is just an equation of a line. I know it crosses at y equals 3, because if the x was 0, so I know it's 1, 2, 3, at least by 3 it's going to cross there, but it's going to go a little bit higher. So I graph this one right here. So let's go back here, home, into my current one. So here's this, f of x is x over 2 plus 3. So they want us to look from -2, which is here. So I'm going to like drop it down here all the way up to 1, 2, 3, 4 and come up here, okay? So what you're going to look like, it looks like kind of like a trapezoid, okay? So you can do two things. You can split it up into two different shapes, or you can do a trapezoid formula. So I'm going to do Control T and bring up your table, all right, so that we have some points to graph. So let me move up here. So we're going to start at -2, 2. So here we're going to go. So I got -2, 2 is a graph, is a point. And then let's do 0 is going to be 3, okay. And then we'll try 2 is going to be 4. Just get from your table here. Whoops, I'm a little off a little bit. I'll try to do this as nice as I can. 2 will be 4 right here. And then when I put in 4, I'm going to get 5. So we're going to have to go up a little bit higher. 4 is going to be 5. So this is the equation of my line. And if they want you to go from -2 to 4, you're actually going to drop it here and here. And that's the shape I'm looking for to find the area. Okay, so there's two ways to do this. You could use a trapezoid formula to find the area, or you can actually put it into two shapes, a rectangle and a triangle. Okay, so if I count this base here, I have 1, 2, 3, 4, 5, 6. And if I come up here, so my rectangle is 6 by 2, and the base of my triangle is also 6, and then it's going to be 1, 2, 3 here. So I have that all kind of mapped out. So I know that if I find the area of this rectangle here, okay, so I have the area of the rectangle is going to be base times height, so that's going to be 6 times 2. And then to that, I'm going to add the area of the triangle, which is 1/2 base times height. So I end up getting 12, and 18 divided by 2 is 9. So there's my 21. So that's kind of what I want you to do on this, is to kind of look at and say, oh, I can find the area of these shapes. And it kind of really makes you understand what finding the integral is. Now, one of the things I want to bring up is this is above the x-axis. So area is positive anyway. But right here, what you get for your integral will match this because all the shapes are going to be above the x-axis. All right, so let's look at number 8. So number 8, let me set up my nice little table here. And then what I'm going to do is they want us to go from 1/2. So here's 1/2. So here's 1 all the way up to 3/2. So that's 1.5. So that's going to be all they want to know this. And it's negative 2x plus 4. So I know this crosses at 4 at 0, so it's not that far. So let's kind of look at what the graph looks like. So I'm going to go to the next graph. So here's this. So I'm looking from 1/2 to 1.5. So it's going to be another trapezoidal shape here. So if you hit Control T and get your tables here, I'm going to go back and look at 0 is 4, 1 is 2, and at 1/2 it's 3. So let's kind of plot our points. So I've got 1, 2, 3. So at 1/2 it's 3. At 1 it's going to be 2. At 1.5 it's going to be 1. Okay, so what we're looking at is the area of this shape. So let's see if I can draw it good. So that's part of the line. Then we're going to drop it down because that's the integral, and we're going to kind of go across here. If you put this in your calculator, you are going to get a 2. All right, so let's see if we can go through here. So this, from 1/2 to 3/2, the base here is 1, and it's only 1/2 high here, not 1. So this should be 1/2 high. No, this is 1. Sorry, this is 1. And then this was 1 here, and then this is going to be 2 here. From here to here is 2. Okay, so the area of the rectangle is going to be 1 by 1, which is really a square, but it's my shape is weird. Plus, all right, we're going to add to that the area of the triangle, which is going to be 1/2, 2 times 1. And so I've got 1 plus 1, so I'm going to end up with an area of 2. Okay, so you're finding the area here, and then you're finding the area here, and then you're adding together.